Good morning guys. So today I'm going to discuss about section 9.5. So especially if you are given a product of two functions, or if you are given two functions as a ratio, I mean consider fx and gx are our two functions. Okay, I will take u and v. So our two functions are u and v. So how we derive this product uv? So we use the product rule for that case, and basically if we are given ratio as u divided by v, then we have to use the quotient rule. So from that names you can find that product rule means if we are given product of two functions uv, how we can find derivative, and if we are given two functions as a ratio u divided by v, we have to use quotient rule. So today I'm going to discuss about these two rules and how we can uh, find the derivative of given function by using these two rules. Now let's look at our lesson. So first I'm going to discuss about product rule. So first let's study what is the product rule. As I said you before, our fx is equal to ux times vx, and then this is the derivative. F prime x is equal to ux times the derivative of vx plus vx times the derivative of ux. So clearly you can see when you are taking the derivative of product of two functions, first fix that function and take the derivative of next one, and then fix the vx and then take the derivative of our ux. So now let's look at some example. So in the first problem it is asking if y is equal to 2 times x to the power 3 plus 3x plus 1 times x to the power 4 plus 4, then find the derivative. So first take, this is your u, this one, and this one is your v. First you need to understand your u and v, then take the product rule. So here it is given that this is u and this is v. So according to product rule, y prime is equal to u times v prime plus v times u prime. So this is the function u, we write it and then take the derivative of this function v prime. So it is 2 times x, and then this is the function v, and then this is the derivative of this ux, u prime. So it becomes 6 times x plus 3. So now you have to algebraically calculate this given expression, and this is your final solution. Actually in a exam also you have to calculate up to the last step. Okay, so again I will remind you, this is your u, and this is the v prime, and this is v, and this is u prime. So here we have used product rule. In section B it is given at the point where x is equal to 1, find the slope of the tangent to the graph of this given function. So clearly you can see this is also product of two functions. You can distribute this one as your u and this is your v. Then use the product rule, then plug 1 for that function. Then you can find slope of the tangent to graph at x is equal to 1 of this function. So clearly you can see they have taken the derivatives. Again let's go. So this is u and this is v. So u times this is the derivative of v prime, and this is again u v prime, so this is the v and this is u prime. So now you have to fix, I mean plug 1 for this given expression, then you can prime the derivative at 1, so it is negative 72. So now I am going to discuss about quotient rule. as I said before, in the form of u divide by v, you have to use a quotient rule. So you can see the function fx is equal to ux divided by v of x, where u and v are differentiable functions of x with specialty is vx is not equal to 0, otherwise it is not defined. Then this is the formula to find the derivative of such expression. So especially you can see this is a little bit tricky. So first you have to write v in here, then the derivative of this one u prime, again u, this one, and then again from this one v prime. So finally you have to divide the total expression by the square of vx. Okay, now let's look at some example. So find the derivative of this one. So take this as your u and this as your v. Okay, so this is your u and this is v. So according to our setup, f prime is equal to u primes times v minus v prime times u divided by square of v. So we have to find these terms separately. So v is already x plus 5, you can see, and u prime is we have to take the derivative of this one, it is 2 times x minus 4. So this is u prime and this is v. Again you have to find v prime is 1 in here, and this is your u, then this is the square of v. So after making this setup, then simplify these brackets and obtain this answer. So this is your final answer. Okay, let's move to our next problem. This is also given as fx is equal to this function. Find the instantaneous rate of change of fx at x is equal to 3. So if they are asking an instantaneous rate of change of anything, so you know you have to take the derivative of that function, and then they are given some particular point x is at 3, so you need to plug in that point 3 for this derivative. So take this as your u and take this as your v. Again make the setup and find the derivative. So now you can see, so first according to our expression I will remain again, f prime is equal to v times u prime minus u times v prime divided by square of v. So you have to find u prime first. So it is this one, and here it is x plus 5 means v minus again derivative of the v prime, and this is your u and this is the square of v. So now simplify these brackets and finally you can obtain this answer. Then it is given that you have to find the instantaneous rate of change at x is equal to 3. So what you need to do now, you have to substitute 3 for this one. So this is your final answer, 1.32. So this is some given application problem, sensitivity to a drug. So specialty in here is you have to use both the product rule and quotient rule. When a medicine is administered, a reaction measured in change of blood pressure or temperature can be modeled by this given mathematical model. So where C is a positive constant, so this C is a constant, and M is the amount of medicine absorbed into the blood. So M is the amount of blood. The rate of change of R with respect to M is sensitivity of the blood to medicine. Find the expression for sensitivity S as a function of M. So clearly you have to take the derivative of this function R with respect to M. But you can see this is a product of two functions. This is u and this is v. So first use the product rule. uh, so you can see this is your u and this is v prime plus v times u prime. Then take the calculations. I mean, here you have to do your algebraic calculations. Then this is the final answer. So okay, thank you everyone, and let's meet on next day with our next section.